So I want to look at one more thing, writing equations. Here's a graph which has a couple of points labeled. So we're going to write an equation for this line in point slope form. The first thing I want to do is identify a point. So I'm just going to pick this one. You could choose either one, but you guys were not fast enough, and one of your classmates already said -1, 3, and so I'm going to go with that. And then we'll also need to find the slope. So between these two dots on the graph, I'm going to find the rise and the run. I don't have MathCat to help me this time, but I can count squares on my own. So the rise, it's going down 2 spaces, and the run is going to the right 2. So my slope as rise over run, -2/2. I can reduce that fraction. I can clean it up. I could just do the division, -2 divided by 2. It's going to be a slope of -1. Okay, I'm going to put that slope into the slope box of my equation, and then I'm going to put the x coordinate from this point that we chose, the -1, into my x box, and the y coordinate of 3 into the y box. Final answer. We can clean it up, but this is the final answer. What if the other part of the class that was saying we should use 1, 1, what if you guys had had your way? Then what would happen? So my y coordinate, I'll write this, I'll just go from left to right through the equation. The y coordinate is 1, so I'm going to put a 1 here. Slope is still -1, and my x coordinate also is +1. And so now this has an interesting phenomenon where part of the class has one answer and part of the class has a different answer. And that's not supposed to happen, right? Some people got y minus 3 equals -1 parentheses x minus -1. We could clean up the double negative if we wanted. And some people in the class are going to get this other answer that I've highlighted in blue of y minus 1 equals -1 parentheses x minus 1. And let's see if we can make things more confusing for a minute before we clean this up. What if I look at this graph and I say, you know what, there are 2 points that are drawn on this graph, but I can actually see more points. What if I had used this point right here, which was not a labeled point, but I can see that the line clearly goes through that intersection on the graph paper. And so that would be point -2, 1, 2, 3, 4. And so the x coordinate of -2 goes in the x box over here. Slope does not change. That's still -1. And my y coordinate was 4, so I'm going to put a 4 right here. So now it appears that there are 3 totally different equations that we've got for this line. What if we found one more point? I mean, just to make things even more weird, I've got, let's see, what colors did I not use yet? I guess the red will work. There's a point down here. I'll use this red dot. So that would be 3, -1. So if I drop the 3 and the -1, 3 is the x, -1 is the y, slope is still -1. Okay, so now you kind of catch the idea. It appears that there are an unlimited number of different equations that are possible, depending on which point we have used for the coordinates. Okay, so this is both a strength and a weakness of point slope form. On the plus side, the strength, we're not limited to using just this one special point to get our equation. That was true when we did y equals mx plus b. You had to have the y-intercept. It's the only option. You need the y-intercept, not any other point on the line. And if you don't know the y-intercept, you're going to have to do more work so you can find the y-intercept and get your equation. So with point slope form, that doesn't matter. You can use any point you have the coordinates for. If you've got multiple points, you can choose any of them. So there are more options, and that's usually a good thing. The drawback or the weakness is that since there's not standardization, we don't have to use this one point every time, it makes it look really confusing because we just came up with 4 different equations for this same line. And that doesn't seem like that's a good thing because now you're like, I don't know which one is right. Is this a green one? Is it a blue one? Or one of these other two that I didn't highlight with the color? the actual answer is they are all the same equation. I know they don't look that way, but if I were to take any one of these equations and solve for y to put it into slope-intercept form, I'm going to get the exact same equation every single time. So even though point slope form has a lot of different varieties and they look different, they're not. They will all prove to be mathematically equivalent. So maybe we'll just take two of them. Let's take these first two and see what happens if we solve them for y. So y minus 3 equals negative 1, x plus 1, and the blue one, y minus 1 equals negative 1, parentheses, x minus 1. Let's find some workspace down here. Okay, so let's do the green one. So I'm going to distribute this negative 1 first. So negative 1 times x is negative x, and negative 1 times 1 is 1. And then to get the y by itself, I'll have to add 3. Do the same thing on the other side of the equal sign. So y, oh, where'd that equal sign go? I lost it. Y equals negative x, and negative 1 plus 3 is 2. All right, let's do the same process with this blue one. If I distribute that negative 1, I'm going to get negative x plus 1, add the 1 to get y by itself. That is the exact same equation both ways. I could have taken any of the other equations. I'm not going to do all of them, but I could take any of them and I'll always get the exact same result when I change it into slope-intercept form.